Hello and welcome to Algebra 1, Chapter 9.5, and today we're discussing exponential functions. So thinking all the way back to the beginning of Chapter 9 was called Quadratic and Exponential Functions, and so we spent the first 4 sections talking about quadratic functions. We're going to finish these last 2 talking about exponential. So keeping in mind, first of all, that these are functions, so once you graph them, they will always pass the vertical line test. An exponential function is one that comes to you in the form y equals a to the x. So your exponent is a variable, okay? A, in our case at the moment, a is going to be something greater than 0 and not ever equal to 1, because if you had 1 to the x, you're going to graph a horizontal line because 1 to any power is just 1. So never will a be 1, but it's going to be something positive. And so you're going to graph this just like you would graph anything, and that is with a table of values. So since we have no idea at the moment what these are going to look like, you're just going to start with your table. And it wants the y-intercept. Well, the y-intercept on the y-axis, x is 0, so the best x to start with is 0. So you get y equals 3 to the 0, and anything to the 0 power is 1. So we got a point at 0, 1. And let's just find some more points. What if x is 1? Then we have 3 to the first power, which is 3. If x is 2, we're going to have 3 squared, which is 9. And if I go larger, right, if I put in 3 or 4, we're going to be off our graph. So let's go back the other way and put in negative 1. So you get 3 to the negative first, which you need to remember an exponent is never, ever, ever going to turn a positive number negative. But what a negative exponent does is it moves a number to the bottom. So, negative 1 is 1/3. If I put in negative 2, that's going to be 1 over 3 squared, which is 1/9. So going back and remembering your exponent rules. Now, the closer, or I should say, let's do this. The more negative I get, so if I put in negative 5, negative 6, negative 7, they're all going to move the number to the bottom. None of them are going to make my positive 3 become a negative. And so you have what's called an asymptote, that it is never going to touch the x-axis. It's going to come in along the x-axis. Oops, I got a little farther south there. It's going to come in along the x-axis, and it's going to curve and go up and hit these points. Okay? But you could sit there all day long with your table and type in, negative 3, negative 4, negative 5, negative 10 for your x's. Let me see if I can get the calculator to help me. I don't know all those off the top of my head. Wow, so that's 1/27. Let's see, 1/81st, 1/243rd, 59,049. So you see these numbers are going to get really, really small. They're never going to get to 0 because you can't turn a positive number 0 or to negative with an exponent. Okay, so don't touch that x-axis in there. It did want our y-intercept, and our y-intercept is the 0.01, or you could just say that our y-intercept equals 1. So that is the graph of an exponential function. So let's look at another one, okay? You're just making a table, and I would always start with 0 because that is going to give you your y-intercept. So 7 to the 0 power is 1, because anything to the 0 power is 1. So my y-intercept is at 1 again. And then if I put in 1, you got 7 to the first, which is 7. Now, I don't want to put in a 2 because I don't want to graph all the way up to 49. It makes sense. If I put in a 2 for x, y is going to be 49, and that does not fit on my graph at the moment. So let's come to negative 1. So 7 to the negative 1 is 1/7. That negative exponent moves it to the bottom. Okay. Now, if I wanted to do negative 2, that would be 1/7 squared, which is 1/49. Okay, and I'm going to get closer and closer to 0. I'm never going to touch 0. So I'm going to come in along the x-axis and come up. Alright, so now I have one that happens to have a fraction for my a, and that is fine. You're going to do the exact same thing. I'm going to start with 0, and any number to the 0 power is 1, and you're going to make sure that you put your fraction in parentheses if you're putting this in your calculator. If you don't, you're not taking that whole fraction to that exponent. Okay, so state the y-intercept. My y-intercept is again 1. It's not always 1, just happens to be here lately. So let's do to the first. So 1/4 to the first. Well, that's going to be a 4th. So that is lower than my last one. So this one's actually going to come the other way. If I put in a 2, that's 1/4 squared. A 4th times a 4th is a 16th. It's even lower. Okay, this time it's coming down and coming along my x-axis to the right. So I need some more table here. Let's go back and do some negative ones. 1/4 to the negative first. It actually gets the reciprocal in there, and you get a 4 out of it because the negative 1 goes to the top and the bottom, and it flips it. So negative 1 up to 4. If you don't remember your exponent rules, I'm thinking like chapter 7 off the top of my head. Negative 2, now this one I'm not going to want to graph. It's going to flip it and square it, and you're going to get 16. And I'm not going to want to put that one on my graph. So this one comes down this way and along the x-axis. And notice I went pretty vertical there, going up between 1 and 2, because it's going to go up to 16 before it hits 2. Alright, so we have it graphed. Then it says to determine a value. Determine the value of 1/4 to the negative 1.5, and then use a calculator to confirm it. Okay, so if I come to negative 1.5 here on my graph, and I come up to the graph, let's see, I'm going to say it's someplace around 6. It's kind of harder on here, but you think you can be a little more exact on your paper. So I'm going to say that 1/4 to the negative 1.5 is 6. That is based on my graph, which is why you really want to have fairly accurate graphs. So if I do this in my calculator though, because it does say to use a calculator to confirm it, so if I type this in and you put it in parentheses or change it to a decimal first, 1/4 to the negative 1.5, I actually get 8 in my calculator. So maybe your graph was more accurate than mine, and maybe you got 8 on yours. And so this shows you, obviously I was not very accurate. Hopefully you are a little more accurate. We want to try to be as accurate as possible on our graphs. So let's try one more time to see our accuracy, and this time we have this extra here, this +2. That is going to actually move our graph up 2. Alright, so I'm going to still start with 0, but this time, so we get 1/3 to the 0 plus 2. So this becomes 1 plus 2, which is 3. Just following our order of operations there. So my y-intercept is 3. And then I'm going to come to 1. I'm going to get 1/3 to the first plus 2, which is 1/3 plus 2, so we get 2 1/3. Okay, and so we're coming down, and what you're going to see, I'm going to jump out to 5, is that there's nothing that's going to make it cross over under 2. So I need to use my calculator for this one. And I'm keeping it, nope, I'm not keeping it as a fraction. The calculator didn't like it as a fraction. Oh, I typed it in wrong anyway. About 1/3, I did 1/5. All right, so this is 1 over 243 plus 2, so this is going to be 2 and 1 2/43. Okay, you're getting really, really close, but you're not at 2. Okay, so it's coming down as we go to the right. We go ahead and go to the left and type in a -1. -1 is going to make it become a 3 plus 2, which is 5. And then let's see if we can fit in a -2. -2 is going to give us a 9 plus 2, which is 11. So we can fit that on our graph here. So this one is coming down. Oops, I forgot to curve down and turn along 2 there. Don't cross over 2. That's your asymptote. And again, we want to use our graph to approximate at -1.5. So at -1.5, if I go up to my graph, okay, I'm going to guess someplace around 6.5. And so see what your graph says. And then what we're going to do is we're going to actually plug it into the calculator and see what the calculator says. And the calculator says 7.196. So closer you are to that, the better your graph is there. So that is what 9.5 talks about, exponential functions and graphing them. So you're either going to have ones, this is called growth, that comes this way, or you're going to have ones that are decay and they come that way. And we will talk more about growth and decay in 9.6. Let me know if you have any questions. If not, have a great day, and I will see you in class.